Hey, what's going on, guys? Let's do this problem right here. The question is asking determine if the following series converge or diverge, right? And we have this one right here. And let's see how we can compare. So first of all, if you take, for example, so let's compare the number first. So we have n cube plus 1, right? N cube plus 1, and we have, let's say, n cube. If you notice, this one is this one is bigger than this one because we are adding one more to this number, so this is going to be definitely bigger than this one, so we can say this is bigger than this one. And if we divide this one, 1 over n cube plus 1 over n cube, so this is true for when n is greater than or equal to 1, right? So here we have this one, and if we divide, this is going to be smaller than this one because we are dividing this one by a bigger number, so this is definitely going to be smaller than this one. So, and if you notice, this is a p series. We know that when we have a number power n, that's geometric series, and n power a number, that's a p series. And here we have n power a number, so this is a p series, right? So we have to know the p series rule. If the power is greater than 1, that is converges. If the power is less than or equal to 1, that diverges. So let's note that one down right here. So if the power is less than or equal to 1, it diverges. So less than or, power is a, right? Power is a. So if the a is less than or equal to 1, right, it diverges. So this one diverges, and here this one is greater than 1, this one converges, right? So here this one converges, and let's take the cube root. So we have cube root right here, n cube plus 1, and then we know this is going to be bigger than that. Cube root of n cube, that is equal to 1 over n. This one now diverges. If we take the cube root, this one diverges because we have power 1. According to the rule, if it's less than or, if the a value is less than or equal to 1, this one diverges. So now this one diverges, but we can conclude if this one diverges, because if you notice, this one diverges, but this is bigger, right? Bigger. This is smaller. So let's say this is infinite number, so that's why it diverges. But if this one is infinite, we can't conclude the number less than this is infinite. It can be a finite number or infinite number. So this maybe converges or diverges. So what we can do is, if I take a number that is smaller than that and prove that one is diverges, then we can conclude this one diverges. But in this case, if this converges, then smaller than that should be converges too. But if the bigger number is diverges, we can't say smaller numbers diverges. So we have to get a smaller number than that and prove that one diverges or converges. So let's take a smaller number. For example, if you take 1 cube root of n cube plus n cube, so this, if n is greater than 1, this is definitely going to be greater than this value, right? Greater than this value, because less than this value, because we are dividing a bigger value, 1 divided by a bigger value than this, so this is going to be smaller number than this. So if we prove this one diverges, we can say this one also diverges, because if the smaller number diverges, if the smaller number is infinity, and any bigger number, then that should be also infinity. So let's see whether this one gives us diverges. So let's write this one in a different side. So let's say, so I'm taking this one around and see what happens. So we have cube root of n cube plus n cube. So that's same as cube root of 2n cube, right? And what we can do is we can separate this one, this cube root of 2 still stay in this one, and n cube can be taken out, so that's going to be n if we take this one out. And then if we want to write in a summation notation, we can write this one as, since this is a constant, 1 over cube root of 2, and we have 1 over n right here, and this is going from n1 to infinity, and this one definitely diverges, right, because power is 1, and according to this rule we know that if the power is equal to 1 or less than 1, this is diverges. So this one diverges, and already we proved that this one is smaller than this one, right? So this one is bigger. This is now if you compare, this is bigger, this is smaller, this is diverges, so this one also diverges. So finally we can say this series diverges, and that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.